Okay, so thank you all for joining us. This session is going to be about NFV Plugtests, the challenges and the latest results. First of all, I am Silvia Almagia. I work for ETSI. I am a technical expert within the Center for Testing and Interoperability, and I'm leading the NFV program, NFV Plugtests Programme.
My name is Pierre Lynch. I'm with IXIA/Keysight as a lead technologist, and I'm here mostly because I'm the TST working group chair at ETSI NFV.
Okay, so first of all, a little bit of context on ETSI in case you guys are not familiar with it. So ETSI is an organization developing ICT standards for global use. It has around 800 members worldwide, and it's contribution and consensus driven, the work we are developing. It's hosting a number of different projects and technical committees. You might be familiar with some of them, like 3GPP, 1M2M, NFV, this is why today we're here presenting, but also multi-access edge computing, zero-touch management network, and lately the open source MANO project as well. Okay, so within ETSI, as I was saying, I work for the Center for Testing and Interoperability, and our role is to provide support to all these groups and projects with different expertise, with different tools and best practices, and also providing technical management of POC frameworks, plug tests, or hackfests. So first thing I will do now is to explain a little bit the concept of plug tests. Most of these ETSI groups I presented are developing specifications on paper. And while this is happening, out there are a number of implementations that are being developed. In principle, out of these specs, it should be possible to generate a diverse and interoperable ecosystem pretty easily. And in order to accelerate this, the creation of such ecosystem, what we are doing is creating these plug test activities where we invite early implementers of those specs to come, to get together, and to give it an early try and some early testing on those implementations. The idea here is not only to foster interoperability and to make sure that these implementations can work together and can interoperate, it's also to gather feedback, not only on the implementations. This is a very nice side effect of the number of bugs and issues that are fixed in the implementations themselves. But we managed to gather a lot of feedback and to fix a lot of issues in the specifications as well. And this is the main goal of this plug test activity.
Now, I'm going to give you a little bit of background organizationally and technically as well before we launch into plug test results and the organization of that. So the NFV community within ETSI is made up of about 315 participating organizations. It's really important to understand that it is totally contribution-driven and consensus-based in the sense that there's no top-down management coming down saying, thou shalt build this. Everything is driven by the membership and the people who participate in it, and then it bubbles up. One important factoid is that you do not have to be an ETSI member in order to participate in ETSI NFV. It's organized in 6 working groups. The main ones are called IFA and SOL. So IFA is interfaces and architecture. They're responsible for the overall NFV architecture that I'll show in the next slide. And Solutions Working Group is responsible for taking their specs and producing both the data modeling, mainly the data modeling based on the information modeling, and also the packaging specs, and also the API specifications as well. Everybody has input into those 2 main groups, where some people can produce reports that become later specs. And my working group down at the bottom tries to test everything that's coming out of IFA and SOL. Okay? This is the architecture that I was referring to. I think everybody pretty much knows what it is. It's the basis for what we'll be doing. Sylvia will drill down a little bit and show you how we decomposed it for the various companies that come and participate in the plug test. It's not one per box like you would think. You'll see in a second. But I mainly wanted it to introduce this, and I'm not going to go through the whole thing. But this, if you can get, if we can upload our slides, is a handy cheat sheet of where the documents lie that specify all the different reference points, the APIs, etc. The stuff in green, in red, is all stage 2, so it's architecture and then the information modeling for all the reference points and APIs, while the stuff in green by the solutions group is all the definitions, so the REST-based APIs, JSON-based, and ultimately open API definitions for all those APIs. It's very handy. It's also showing that all the work that's been done by this group since the 5 years they've been around, right? So, Release 2 is the release that everybody looks at right now. It contains that architecture, all the functionality, et cetera, and it does include the data models and the APIs. It starts, from the design point of view, goes into a deployment, but I mainly wanted to use this slide to show which parts of the architecture are responsible for what within the scope of NFV. And first of all, dividing it up a little bit on network service, VNFs, and then the infrastructure. So first of all, the NFVO, the orchestrator part of MANO, is responsible for end-to-end network services. Okay, so it's responsible for chaining multiple VNFs together and PNFs, so physical network functions as well. But all that functionality comes out of the orchestrator part. Then the VNFs themselves get managed by the VNFM. Okay, so that's really the division of responsibility in this architecture, which sometimes gets left out of the discussion. And when I talk about network services, I view the NFV architecture literally as just a platform to be able to run VNFs. ETSI NFV doesn't care what's running in the VNFs. We never look at the application. It's out of scope for us, okay? It's a tight scope that started there and is still maintained to this day, okay? And the northbound interface goes to the OSS BSS, okay? It was always maintained that way. And then last but not least, obviously, the NFVI plus the Vim. So this is where OpenStack fits into most of the deployments that we see today, and certainly the deployments that come into the plug test, which is responsible for all the virtualized resource management. Okay. So just step you through, and I don't mean to get detailed here, but it's just to show, well, a scaling example of the interaction flows or the interactions between all the different blocks within MANO and Vim to show why the interop is so important. The plug test becomes such a big deal. And this is just a scaling example with the slide itself shows only two possible triggers, either from the VNFM that by reading KPIs from the VNF decides, yep, time to scale out or in, or it gets a request from the VNF or the element manager itself to scale. The one that's not shown is the Vim can also trigger a scaling action through KPIs sent by OpenStack or whatever Vim happens to be there. Then it triggers a bunch of actions. Typically, this is not scope of the plug test here, and you'll see why in a few minutes, but there's a granting and then an allocation of the virtualized resources. So there's communication between all the blocks within this architecture. Now, if different manufacturers come in with different blocks of this architecture, there goes there's the interoperability test, which is the plug test itself.
Okay. So for NFV, we created this NFV Plugtests Programme in order to provide an environment to running this interoperability testing. The idea was to provide a platform and a framework to run this testing in a collaborative manner by all the participants that were implementing different NFV blocks, so that they could run these tests not only when they come to a face-to-face plug test event, but also remotely from their home labs. It's worth mentioning that ETSI does not certify or endorse the participating companies, but we're there to make sure that the testing can happen, to provide a venue, a network, some methodology, a test plan, and the actual testing is run collaboratively by different participants bringing different NFV components. And participation to these plug tests is free and open to any organization that wants to bring something to test or to support the testing. So if I move on, the first challenge, okay, how do we build such a worldwide collaborative environment that enables this remote testing? The answer was to use Hive. Hive is the hub for interoperability and validation at ETSI. It's a fancy name for a big router, but actually enables us to connect in a secure manner all the participating labs or sites to ETSI in such a way that they can access each other's facilities. We provide a VNF, a central VNF repository where they can upload their software images, they can upload their descriptors that are going to be used by the testing. And we have currently over 45 remote sites connected to this Hive, over 60 organizations, and over 250 people that are actively interacting and running testing over this setup. When it comes to participate to plug test, and we were saying participants are going to bring different blocks and different components of the NFV architectural framework, we try to simplify a little bit because this is a complex diagram with many different boxes and the number of combinations could grow extremely high. So to start with, we simplified a little bit this setup and grouped the different functional blocks in 3 big groups, okay? So we started with the platform. This corresponds to what Pierre was saying on the Vim and NFVI, and possibly what OpenStack and other Vim providers are developing. The second block is the MANO solution, which includes NFV orchestration and generic VNFM capabilities, the 2 upper functional blocks of the MANO. And then the third big block is the VNFs, which can bring or not their own element manager, and which can bring or not their specific VNF manager. Okay, this is their choice. And the idea is to test interoperability among these 3 big blocks. Okay. In terms of open source presence in these different blocks, we do have nicely some groups present on each of the 3. So we have, of course, OpenStack, OpenDaylight, and OPNFV present in the platform. We have open source MANO, OpenBayton, and Sonata project that are developing open source solutions for MANO. And we have lately has joined the NFV Plugtests Programme, Open Air Interface, who are developing access and network capabilities for 4G and 5G, future 5G networks. Okay? In addition to the presence of these open source communities, we do have a lot of vendors that bring their own products that are based on open source or not, and that sometimes they are teaming up together to provide one of these big blocks. Okay? So this is the latest picture of the participation on the Plugtests program. We also have a number of service providers that are supporting and participating to these Plugtest activities as observers and actually providing input and revising the test plan and providing also additional contents for it. So a little bit of history. We organized and ran the first Plugtest, NFV Plugtest in January 2017. This happened in Madrid, in Spain. We had 31 brave participating organizations that signed up. They didn't know to what exactly because it was the first time we were doing this for NFV. And we came up with a very good balance of platforms, MANO solutions, and VNFs. We actually had 11 platforms, 9 MANO solutions, and 15 VNFs that got tested in different combinations over 2 weeks on site. The scope of the testing was not very fancy, it was very basic functionality. It was about onboarding, instantiating, scaling, updating, and terminating network services, most likely made with one single VNF. But the challenge and the value of this testing didn't come from this basic functionality, but from the number of combinations that we managed to run. Okay, so the idea was that over 160 combinations of different MANOs, platforms, and VNFs got tested and went through the same test plan. After this, in January this year, we organized the second NFV Plugtest. So this happened in ETSI premises in Sophia Antipolis in the south of France. We reduced the duration of the event to just 1 week, but because there was a lot of things that we could do remotely in preparation over this Hive network. We had an increased participation there. We had 15 additional organizations that joined. And we took also an opportunity to co-locate this Plugtest event with the first open source MANO Hackfest and to start building some kind of synergy with open source projects that are implementing NFV. Okay, the scope of this second Plugtest was a bit broader. In addition to the basic testing that we ran during the first Plugtest, here we started looking at multi-VNF network services, more complex network services, about fault and performance management. And we started looking about auto-scaling triggered by different triggers, as Pierre mentioned. We'll see that in the results, which were the different triggers that were exercised. We also started looking at additional aspects in optional test sessions, like enhanced platform awareness, like multi-site deployments, which was something we were not really sure we could do over Hive, and it came up pretty nicely that Hive supported these multi-site deployments, and MANO solutions were able to orchestrate different platforms over this network. And we also provided some specific test groups for those VNFs that started bringing their own VNF managers. In addition to that, we started experimenting with automating all this testing. And by January this year, NFV ISG had done a lot of progress in the development of NFV APIs and open API definitions for those APIs. So we created an additional track on API validation. This was a bit experimental, and it's actually contributing to a new work item in the TST working group. For developing the test plan, we're actually following a methodology that is described in TST2, one of the specs that NFV TST has published. The idea here is that we look at the basis specifications that these IFANs or working groups are producing, but not only. We also capture input from participants to the Plugtest, and we also look at what different open source communities are doing in the area of NFV. With all that, we come up with different possible test configurations, different ways of combining these basic blocks I mentioned before. And on top of that, we are going to develop a number of test descriptions that explain a number of conditions that need to be met for the test to be able to be run, and then very specific steps, triggers and checks that you need to follow in order to verify that the test has been successfully run. The idea here is that the test plan is written at a functional level. We don't look at how things happen, but at the end-to-end kind of feature that we are trying to validate. And this needs to be implementation agnostic so that any possible solution that's aligned with the ETSI specs can run through that testing. Okay? It's not tied to any specific solution. Okay, remote pretesting. As I was saying, we were able to reduce the duration of the Plugtest thanks to a number of things that were done remotely over the Hive network. What we make sure is that participants get connected as soon as possible to this network and that they are able to run a number of sanity checks on the integration of different components, connectivity, of course, but also that the platforms have created credentials and tenants for the MANO solutions, that the software images of the VNFs have been uploaded, that the descriptors are being created, and that all that is being made available in a location where all the participants have access. And we try to encourage that some basic testing is run remotely before actually coming to testing. And this for as many combinations of these big blocks as possible. When we get to the on-site event, then we try to make sure that we make very efficient use of the face-to-face time. We come up with a very tight schedule of test sessions. We have tools to provide some kind of semi-random schedule that we discuss with participants in order to make sure that we're not trying to test something that's completely unachievable. And we try to make sure that all the organizations and people participating to this Plugtest are busy all the time, get a chance to test with as many testing partners as possible, and that they really make good use of their time. So this is, for example, in the slide you're seeing, this will be for one day. We will have a number of test tracks, a number of sessions, probably 1-2 sessions in the morning, 1-2 sessions in the afternoon for each company participating. On these sessions, we will have one MANO solution, 1 or 2 platforms, depending if you are testing multi-site or just one site, and a certain number of VNFs that are required to build the network service and to get the network service through the testing. And finally, we try to capture all these results, okay? We try to learn from what happened, and we try to make sure that all the tests that is run during this event is reported. So we have a tool for that. The organizations participating to a test session will enter the results. We'll agree all the people that were involved in the test session need to sign the report, need to certify themselves, self-certify that this is what happened, and these are the results that were captured. And this tool keeps these results private for the participants, but starts generating stats. And it allows us to see for each test case, for each test group, how are the things going, which are those that are being very successful, which are those that are not being run at all, which are those that are failing. And it provides very, very good insights in the maturity of the test plan, and the maturity of the base specifications as well.
Okay, so let's get into the results a little bit. Before I start, 2 things. All of this is in the plug test report. So everything I'm about to show you, and actually everything we did show you, is available in test plan report. Second thing is only results at an aggregation level are shown. Never individual test sessions, never companies named, etc. That part is private. The rest of it is just statistically relevant per test case or per plug test itself here. So this slide shows the results. Well, the overall, this is really the 30,000 meter view of what happened. And let me explain the columns a little bit. So you've got the results, number of test sessions is what we've been talking about. The one cool thing is compared to the first plug test, which had 160 test sessions run in over 2 weeks, this time we ran 189 test sessions over 1 week. So a heck of a lot more pre-testing got done, but also it shows a maturity, meaning we're succeeding more, and you'll see that in the results as well. Then there's 2 group columns, okay, and what is it? I'll need my glasses here. Sorry about this. Okay and no, and those refer to the test cases actually run, okay? So the third column is important, NA. NA means there was a test case, but one of the 3 participants, one of the 3 blocks, couldn't support the exact functionality there. So what it means, if you look far to the right, 70% of the test cases were run and 30% not, okay? Now, of the 70%, then you look at the okay or no columns. And so there was a success rate of everything that was run of almost 95%. Which itself is leaps and bounds over the results of the first plug test, which are shown here, green instead of blue. But the success rate increased dramatically, going from plug test 1 to plug test 2. So that's a great sign. It means we're moving forward. Let's look at more details now. So 2 different groups of testing. There was a pre-testing and then multi-VNF, and these were considered the mandatory. Everybody was trying to run these at least. There was 88 and 76 sessions for each. And so the pre-testing, 80% of it got run, and of that, 99% successful. 60% of the multi-VNF got run, and of that, 88% successful. So again, we're showing that the industry is moving forward by even having the ability to try these test cases, and once they do, they are successful. So it's a good sign. Again, compared to the first one, the pre-testing, the first bar in blue is pre-testing for second plug test, while as the bottom one in green is overall results for the first plug test, okay? Again, improvement. A little bit, no, I won't go through all of these, but this is how the test report categorizes them. But this gets into the multi-VNF and all other types of test cases here, the multi-VNF subgroups. So you've got basic, and here's where you'll see the performance management, fault management, and scaling. And you'll see for each, there's VNF scaling and then network service scaling, both 3 types. So it's 3 types of triggers to trigger the auto scaling. Now this excludes manual scaling, which was the majority of the scaling that got done in the first plug test. Now we've moved on a step further and we're trying auto scaling. And the success rate there, the run rate was 42, 75 or something like that, but the success rate of those that tried, again, improved. So this is like, we're not perfect yet, but we are improving, and we expect even better results in a third plug test that we'll go through. And then we got into even fancier test cases here. So multi-VNF EPA, enhanced platform awareness, looking at things like CPU pinning, huge page sizes, specific requirements on hardware acceleration, and seeing if the onboarding and then the instantiation would respect those policies. Multi-site test cases were attempted with a 100% success rate of those who tried. And then the surprising thing for us is the specific VNF. So people that have a VNF manager hooked on to their VNF, taking care of just their VNF, was opened up as a possibility, and 0 people tried. It was like, oh, okay, but it's still open for the third one. And then a new suite of test cases called Auto Lifecycle Management Validation, where we brought in tools that helped automate those test cases, was brought in as well, and we'll keep going to the third one. And that one had a high success rate as well. Now, lastly is what Sylvia talked about earlier, the experimental track around APIs. We called it experimental because the APIs had just been baked. They were just released. It was really, really quick. So not a lot of people had a chance to implement them. So they put together, what is it, I think 29 test cases, partially covering 5 out of 17 different APIs, which some of them are on the same reference points, covering different parts of functionality, all based on 2 API specs called Solutions 2 and 3. And that, we had a handful of companies that were ready to give it a shot. ETSI CTI had built a small test system to be able to test for the conformance of the messages and syntax and stuff like that and content. And it came out okay. You know, given the fact that this was in January and the specs just got released a month or 2 before that, you know, it wasn't bad at all. And this, from early indications, we'll have even more participants in the next plug test that are going to give this a shot.
Okay. So I mentioned before, during the second plug test in January, we took the chance to co-locate the first OSM Hackfest. The idea here, this was a parallel activity managed by the OSM community. But the idea here is that the participants that wanted to join this got familiar with using OSM and getting descriptors done for OSM and doing basic troubleshooting. The setup relied on another instance of Hive. We were connecting some community labs to ETSI through another instance of this Hive. And something really nice that happened is that while the participants of the Hackfest were getting familiar with troubleshooting OSM, they could start addressing real problems that were being detected in the plug test and start troubleshooting for real things that were coming up and that needed quick fixes to continue the test sessions. So this was kind of nice. This was the first Hackfest and worked pretty well, and this community is has organized a second one lately, and it's currently working on organizing a new one end of June in Oslo. Participation to these activities is open and free for anyone that wants to join. Pierre was mentioning the plug test report. Okay, so with all the information that we captured during the preparation of the plug test and the test sessions, we put a report together, and we make sure that main learnings are contributed back to ETSI NFV. So of course, the test plan is contributed to TST 10, who's dealing with interoperability testing guidelines. But also in the Plugtest report, we try to capture these overall results that we were presenting, the participation, some technical arrangements that need to be put in place to run the testing, and also feedback on the specs, feedback on the different test plans, feedback on the APIs. And from this experimental API track, we capture some feedback as well that is now being fed back to TST 10. So the previous one was 7 then. Who's dealing with NFV conformance, okay? And the learnings of those experimental sessions are going to be part of the methodology for testing NFV conformance over those APIs. So what's next? The third NFV Plugtest, of course. This is happening next week. We're going back to ETSI again, Sofia Antipolis. It's going to be a bit longer than the previous one. We're going to run this for 2 weeks. And the reason is that we're not only running interop test sessions and API tracks, but we're also aiming at running some demos, and we will be co-locating an OPNFV Plugfest at the same occasion. So for the scope of the interop testing, we are extending it a little bit, not that much. It's only been a few months since the previous Plugtest. The specs and the implementations haven't changed that much, but there are a number of aspects that we want to look at. This is, for example, scaling to level, which was not addressed in the previous Plugtest. This is about running further fault and performance management test descriptions. We are going to give a try at VNF forwarding graphs and service function chaining. And of course, we keep covering the scope of the previous Plugtest with enhanced platform awareness and more multi-site, and hopefully some specific VNFM managers. We keep increasing the amount of test cases that will be automated, and we are going to extend as well the API track. Hopefully this time will be less experimental, will be more supportive, those APIs, and we're actually extending the scope to Sol 5, which is the northbound API of the MANOs.
So for the last one, we were able to co-locate with OSM Hackfest. So we had a big group hug there with that community, and that worked out pretty well. So this time around, we get to do it at the same time as OPNFV. The two groups, the two communities have been collaborating since day one, especially on the testing side. But this is the first time that we'll be able to hold a Plugfest/Plugtest at the same site, same time. And what that opens up is a series of things. And first of all is, with all the commercial vendors that come with VNFs at the ETSI Plugtest, it enables OPNFV to come in, OPNFV participants to come in with an OPNFV platform and have commercial VNFs run on the platform, which is a little difficult to do sometimes. So it opens the door to possibilities that they don't normally have. Secondly, they get to try fancy features that were developed as part of OPNFV project, upstreamed into either OpenStack or OpenDaylight, and try them in a Plugtest, again, with commercial VNFs. So things like SFC, the Service Function Chaining project, or BGP VPN, or even the Doctor project, which is all upstream to somebody else and then reintegrated in OpenNFV. This gives them the possibility to test it with a variety of different VNFs. Dovetail is the tool that's used by OPNFVs for their OVP, OPNFV verification program. And it gives them a chance to come there and launch it and test it over commercial platforms. And we've launched a call for participation, and the response was remarkably positive. A lot of people, a lot of platform vendors, there's nothing interop about that, by the way, but a lot of platform vendors did express interest into running the Dovetail test suite over their platform. So that's very cool. And then the other, OPNFV is an integration platform project. But what they're really good at is, as a result of that, is all their test frameworks that they built, either VSPerf, NFV Bench, FunkTest, hopefully, and also Dovetail, gives them a chance to run their test tools and their platforms over participants in the Plugtest. And then last but not least is it lets all the ETSI NFV individuals who come to the Plugtest go into the Hackfest part of OPNFV and learn and meet the people and learn about the projects, because the Hackfest is a series of meetings and basically project meetings where somebody can really quickly get introduced to what's going on there. So it creates an even better opportunity to cross-pollinate across the groups.
Okay, so just to wrap up, yeah, we will have a little bit of time for questions, I think. So this slide, we created it at the very beginning of the Plugtest activity. It was some kind of vision on why we were doing this Plugtest. The idea was that this interoperability testing, these community gatherings, these cross-community gatherings, would allow to create synergy, to align the solutions, and also to close the gaps. There's been in the beginning, like in any other technology, a bit of disconnection between what the specs are saying and what the implementers are doing. Even across implementations, among implementations, there are some different ways of implementing things. And by getting all these implementers together and providing them with a platform that allows for this testing whenever they're ready for that, we're actually capturing feedback, capturing learnings, feeding that back to the specs, and helping to close those gaps and close that disconnection between the specs and the actual implementation. And we do have a bit time for questions.
Any questions?
Could you please use the mic?
Can we please ask you, hold on, I'll do it. Is it mobile? No, it isn't, it's fixed, I'm sorry.
So I was just asking a basic question, like what's the basic difference between OSM and the OpenNFV?
So the difference between OSM and OPNFV, it's, I would start with, there are two different projects, but their scope is different as well. OPNFV is you may want to describe OPNFV.
OPNFV started out as its target is to assemble various open source components to compose NFV platform. And it was at first NFVI, so the hardware and virtualization layer, and then the Vim, OpenStack. And then it's since expanded, and it's bringing in another project like ONAP, so it's bringing up towards the MANO stack and above. But it's mainly an integration project that if it builds features, builds it upstream into other communities, and then reassembles it.
Okay, and open source MANO, it's an open source project that is hosted at ETSI itself. The goal and the scope here is to create the upper MANO solution, providing NFVO and generic VNFM functionality, and they are self-committed to get it aligned with the NFV specification. So for example, they are just releasing an implementation of the Sol 5 Node on API. They are making sure that they are implementing a data model that is compatible with the ETSI NFV information model, and they are providing feedback, active feedback to the ETSI NFV specs group in order to get this to align.
Come on, you gotta say. Release 4 was announced today for OSM. It was literally released today. OPNFV, yes. It does include OpenStack.
Yeah.
So it's the platform plus the Vim. And that's what they bring. They have included more components. That's what the OPNFV platform at its basic is the Vim plus NFVI plus the networking, so ODL, ONOS, etc. There are new projects bringing in MANO, but they're not bringing that specific project into the plug test.
Yeah.
That's why we drew it there.
And actually, within the scope of the plug test, these two projects are interacting and interoperating pretty well.
Anything else? Yes?
So, this is more of an observation, maybe followed by
Observe away, Dave.
a little bit of an observation, maybe followed by a small question. So by bringing OPNFV, the dovetail testing project into this and having it, the interop testing done on those tests, and also observing that the LFN is now responsible for the OPNFV, the testing program, and also ONAP. I understand ONAP will be also adopting if I'm correct, or looking at leveraging Dovetail components, it seems like there would be an inherent interoperability and readiness by all the participants in ETSI if any of them choose to use ONAP. And the question is, do you have any further comments on that? Have you heard anything?
Right now, well, for the first part, you're right. What was called the OVP program is being expanded to ultimately bring in all 6 communities under the umbrella of Linux Foundation Networking. They just named a new chair for that program, Chris Donnelly, this week. And so they're going to expand their scope, yes. Second part, Dovetail is compliance, not interop. It takes a thing and tests it in various methods, in various ways to make sure it's compliant. While as the plug test is take Lego block A, Lego block B, put input into both of them and see if they talk. Are they shaking hands? So it's a little bit 2 different scopes of testing. Having said that, since OPNFV is at the Plugfest plug test, we said, let's open up the doors. You know, it has nothing to do with interop, but let's open up the doors and run Dovetail, which right now, for the time being, is still concentrated on the platform. Run it over commercial platforms. And a lot of them went, let's go.
Cool, thanks.
Yeah. Okay, so I think time's up.
We're done. Thanks, everybody.
Thank you all.
Appreciate it.